Hello. Okay, so this is supposed to help you with your 5.02 sampling quiz and the OLS. So we're going to do a couple of examples and just kind of talk about them and the thought process that goes behind it. So first example, Edwin watched 62 random movies from each nearby video store. Each video store has an equal number of movies. Is this sample of the movies at nearby video stores likely to be representative? So we have to figure out what in the world is he trying to represent, okay? So he is trying to represent the variety of different movies at these different stores. So if they have an equal number of movies, right? We're talking an equal number of movies that at each store. So none of the stores are going to have more of a variety of anyone else's. And he is just truly picking random movies. If we are trying to figure out what kind of movies here are, then yes, this would be representative. There's not a bias anywhere here. There's not a specialty store that might have only thriller movies, that's not a good sampling of random movies in there. They're all nearby, so he is just trying to talk about nearby stores, and they all happen to be nearby as well. So in this case, we don't have any biases or something that would skew the data to a different direction. Next one. Shelley tested 2 light bulbs in each string of lights before hanging them outside. Each string of lights has an equal number of light bulbs. Is this sample of light bulbs from the strings of lights likely to be representative? So we're trying again. What is she talking about? So she's only choosing 2 light bulbs in each string. So those 2 light bulbs are probably not going to be representative of that entire string of lights, because that string of lights, even though they all have the same amount, 2 lights are not going to be representative of that string of lights. There's only 2 of them. Okay, to find what percent of people in a town approve of plans to convert a meadow into a shopping mall, a reporter goes to a nearby mall and asks every 5th person, what is the bias of this situation? So the first one, there is no bias. Everyone had the same chance. So this isn't exactly true. So if a reporter is trying to figure out if people would want a mall in their meadow, and he goes to a mall and asks people who are already shopping at a mall if they would want a mall, he is absolutely having a biased sample. So he is not asking the entire town. He's not asking a variety of age groups. He's not asking a variety of methods. So he is asking if someone who's already shopping in a mall would want a mall. So most likely they would say yes, because they obviously like shopping, hence why they're at a mall. So it said there is a bias sampling due to the location. He's not getting a full representation of that town. He's only getting a representation of people who already shop in the town. And then it says, due to the number of people being asked, he did a pretty great job just doing every 5th person, where he's truly like randomizing his data that way, but it's just where he was grabbing those samples that would have been incorrect. The owner of a baseball stadium wants to estimate the percentage of people attending a game who are in favor of raising ticket prices by 10% in order to make the improvements to the stadium. Which sampling method will give the owner the best estimate? Randomly select 100 seats in the first 2 rows of the stadium and survey the people. Randomly select 100 seats in the stadium and survey the people sitting in those seats. Randomly select 100 season ticket owners, or randomly select 10 of the owner's employees. So which sampling gives? So let's do the first one. Randomly select 100 seat numbers in the first 2 rows. People sitting in the first 2 rows have obviously paid a whole lot more than those who didn't. So they can probably afford a 10% increase, and it's probably not going to deter them, because if they're already willing to pay those higher prices to sit closer to the stadium, then they would be willing to go up 10% as well. So this is not necessarily a representation of of all of the attendees. Okay. Randomly select 100 season ticket owners. Again, this is not all of the attendees. You are narrowing the focus to just season ticket owners. Same thing with this example. We're limiting our survey choices. So we're only limiting it to employees. This next one, this would be the best representative. Just 100 seats in the stadium. Those are all over the place. They could be the front row, they could be the nosebleeds, they could be an employee, they could be a season ticket owner, they could be a first time. It's a really good representation of all of the people attending that game, and we're not narrowing our focus to a specific target. Keith wants to predict the number of baseball fans who like a specific team. Which sample is better for making this prediction? Sample A random sample of 10 baseball fans or a random sample of 100 baseball fans. Keith wants to predict the number of baseball fans who like a specific team. Okay. So when we are talking about which sample is better, right, the more data you have, the better shot you have of getting your predictions correct. So you want to always go with the higher number here. Because again, the more we have, the more data that we can collect, the better our prediction's going to be. The manager of a grocery store wants to estimate the percentage of his customers who like orange juice. He surveys the first 10 customers on a Monday morning. Which statement is true? Select each correct answer. That means there's more than one answer here. Option 1, the manager's sample is unlikely to be biased because the first 10 customers on a Monday morning represent all of his customers. So then again, this cannot be a good representation of all of his customers. He is only narrowing down the people who come in on the first 10 customers on a Monday morning. Early risers, people who maybe don't work on a Monday morning, or something like that. Like, he is very much narrowing his time frame to the number of people he's asking, and he's narrowing it to the time frame. The only way the manager can estimate the percentage is to ask every customer throughout the week. This is a good representation. We're not narrowing the time, we're not narrowing the number of people, we're not narrowing the day of the week. This is actually a pretty good way to get a gathering of whether his store is the percentage of customers who like orange juice. The manager can prove his estimate by randomly selecting customers throughout the week. This can also occur. So again, we're not being biased to who comes in at night and who comes in at morning. We're not biased to who shops on Tuesday and who shops on the weekends. We're not biased to anything like that. So this eliminates most of the biases. The manager can improve his estimate by surveying 50 customers instead of 10. Yes, you want more people, that's great, but he still has another bias of that Monday morning. So again, he's not getting a good representation of all of his customers, just the ones on Monday morning.